Anastasia. I don't understand calc.
Just go take a break. I'll try to work it out.
Pizza delivery!
Who ordered pizza?
Anastasia. How do I solve this cube?
Go to work.
We are going to be taking the antiderivative of 4x minus 11 over 2x squared plus 7x minus 4 dx. In order to use partial fraction decomposition, we need to factor out the denominator, so we're going to be starting off with some side work. Now we will begin by using the diamond problem. So we need to multiply 2x squared with negative 4 to get negative 8x squared at the top, and then we put the 7x at the bottom, and we know that 8 and negative 1 will work for both the top and the bottom. So we are going to be using the rectangle. We put 2x squared on the first box and negative 4 on the bottom. Then 8x and negative x from the diamond problem. If you multiply out 2x with x, you get 2x squared, and negative 1 and x gives you the negative x, and then the 4 gives you the negative 4. So now we can begin the partial fraction decomposition. We get x plus 4 times 2x minus 1 from the diamond problem, and we can use our variables a to separate the bottom. So it's going to be a over x plus 4 plus b over 2x minus 1. So now we have to multiply the denominator by both sides. So we get 4x minus 11 equals a times 2x minus 1 plus b times x plus 4. So now we can let x equals negative 4 in order to cancel out one of the variables. So we get 4 times negative 4 minus 11 equals negative 9a. On the left, we have negative 27 equals negative 9a. So we divide both sides by negative 9, and we get a equals 3. So now we can do the other side, which is let x equals 1/2. We multiply 4 by 1/2 minus 11 equals 4.5b. On the left, we get negative 9 equals 4.5b, and we divide both sides by 4.5. So now we get b equals negative 2. So now that we have our a and b, we can write that antiderivative. So we get the integral of 4x minus 11 over 2x squared plus 7x minus 4 dx is equal to 3, the absolute value of the natural log of x plus 4 minus 2 natural log absolute value of 2x minus 1. And so since we have the coefficient of 2, then we need to multiply by 1/2, and don't forget the plus c.
Oh, I got it! Oh no, tea house! There she goes. Anastasia.
You have been fooled. I am Vector. You will never foil my plan.
Another cube. How do I solve these?
We're going to take the antiderivative of dw over w squared times the square root of w squared minus 7. So for this problem, we are going to be using trig substitution. So we are going to start by drawing a right triangle. On the bottom, we are going to put square root of 7. On the right, we are going to put square root of w squared minus 7. And on the hypotenuse, we're going to put w. So now we're going to be using SOHCAHTOA. So first, we start with cosine of theta equals the square root of 7 over w. Now we need to solve for w. So w equals the square root of 7 times secant theta. So now we take the derivative of square root of 7 secant theta. So that will be dw equals square root of 7 secant theta times tangent theta. Now we're going to be using tangent of theta. So tangent theta equals the square root of w squared minus 7 over square root of 7. Now we need to solve for square root w squared minus 7, which equals the square root of 7 times tangent theta. Now we can substitute. So we start with the integral, and it's square root of 7 secant theta tangent theta. So we substituted that for dw over 7 secant squared theta times the square root of 7 tangent of theta d theta. So now we can cancel out tangent theta with the bottom tangent theta, the square root of 7, and since there's a secant squared on the denominator, we can cancel out the top secant, which now we can take out the 1/7. So it's 1/7, the integral, and then cosine theta d theta. So now we take the derivative of cosine d theta, so it's 1/7 sine theta plus c, and don't forget the negative since it's the antiderivative of cosine theta. So that will equal negative 1/7 times the square root of w squared minus 7 over w, since we substitute the sign by using the triangle, and then don't forget the plus c.
I got it. They're not here.
Let's play around.
Smith Park. Tim, you're finally here! But Vector's still here! No! You locked us in, Vector! No! We have to solve it to get out of here! Oh my god. Okay, let's think about it.
Alright, so we're going to be trying to figure out if this series converges or not. So to do that, we're going to have to think back to the limit comparison test that Mr. Francis taught us earlier in the BC year. But before we can do that, we're going to need to do some work.
So now we have to take the limit as n approaches infinity of our original series divided by a series that you either know converges or diverges. So we will be using the series 1 over n to the 3/2. Now we can rewrite this so it can be much more simple. So we can take the limit as n approaches infinity, and we will be rewriting the square root of n as n to the 1/2 over n squared plus 1 times n to the 3/2 over 1. So now that it's rewritten, we are going to be taking the limit as n approaches infinity of n squared over n squared plus 1. We are going to be dividing each term by the highest exponential term. So now I'm going to be dividing each term by n squared. We know that 1 over n squared approaches 0, and n squared over n squared is 1. So the limit as n approaches infinity equals 1, which is greater than 0.
So if we look back at the limit comparison test, the first rule says that if the limit as n approaches infinity of a of n over b of n equals c, and that value c is greater than 0, then the two series either both converge or both diverge. Since the series we used for the limit comparison test is a convergent p-series, and the p is 3/2, which is greater than 1, then our series is also a convergent series due to the limit comparison test.
Oh, we got it! Yeah!
Oh my god, thank you for saving me, Cam. So look, he has a master plan to make a machine to make everyone else stupid so he can be the only one to pass the AP exam. We have to stop him. We have to go to his secret lair. Come on, let's go. Dude, his car. It has to be close. Come on, let's go.
Secret lair?
It has to be here. Let's go.
Well. Look who we found here. I guess your demo fire plan won't work anymore.
Luckily for you, I have my sister with me.
You can't get past both of us.
Wait, did you betray me?
I brought you here, Kim. What did you think? You can do calculus, but you can't use this brain of yours.
Yes, we have. We have betrayed you.
Now good luck getting out of this one. The room will self-destruct in 10 minutes if you don't solve this.
Sister, if you will close the door.
Oh no, it's locked. How am I going to solve this one? So now we are going to be taking the antiderivative of x times e to the negative 2x dx. For this problem, we will be using integration by parts. The general formula we use for integration by parts is the integral of u dv equals uv minus the integral of v du. Now we need to find our u, du, and v dv. To find what we'll be replacing our u, we will use our helpful tool Lipit. According to Lipit, polynomials go before exponentials, so we will be replacing our u with x, and dv will be e to the negative 2x dx. Our v is the antiderivative of e to the negative 2x, which is negative 1/2 e to the negative 2x, and our du equals dx. Now we are ready to substitute uv minus the integral of v du. The integral of x times e to the negative 2x dx equals negative 1/2 x times e to the negative 2x minus the integral of negative 1/2 e to the negative 2x dx. So now we need to do some side work to find the antiderivative. We can take out the negative 1/2. So as you can see, we already have the antiderivative from the previous time. So this equals negative 1/2 times negative 1/2 e to the negative 2x, which equals 1/4 e to the negative 2x. So now we have our antiderivative. So this results to negative 1/2 x times e to the negative 2x minus 1/4 e to the negative 2x plus c. I got it!
We could destroy the whole world and make them dumb.
After I push this button, we'll be the smartest people alive. No one will pass the AP test except us! Are you ready, brother? 5, 4, 3, 2.
You don't have to go down this path.
You don't understand, Kim. We want to be the only ones to pass our AP Calc exam, and there's nothing you could say to stop us.
You don't have to do this. We can all pass the AP test. Mr. Francis taught us better. We can use the secrets of the universe to calculate well.
Brother, she's right.
I agree.
Let's go study for our AP exam. Thank you, Kim. You've made us see the light.
Thank you, Kim. I appreciate you for doing this.
Let's go study Calc.
Oh! I have my sister with me.
I got it! I got it! I got it! I got it!